All right, today we're going to be learning how to solve radical equations. So, from previous lessons, we know that if we square a square root, we would just be left with x, because squaring and square roots are inverses of each other. Similarly, if we cube a cube root, we're just going to get the number underneath. And if we have a 10th root and we raise it to a 10th power, we just get what's underneath. So, for any root, if we raise it to the index power, we're just going to get x. So to solve radical equations, you need to eliminate the radicals by raising each side to the appropriate power. Similarly to absolute value functions, before we can get rid of the square root, we need to get the part with the square root by itself. So we're going to add 5. We'll have negative square root of x equals negative 1. Divide by negative 1 to get rid of the negative in front of the square root. We get square root of x equals positive 1. Then we're going to square both sides, and we get that x equals 1. Now we're solving, so we need to make sure that we check our solutions. Let's review how to do this on the calculator. We're going to take our answer and store it for x, and then we're going to type in the problem and see if it gives us negative 6. So negative square root of x. Make sure you arrow out of the radical because the radical stops before the negative 5. Minus 5, and we got negative 6, so we know our answer is correct. So number 2, we're going to start off by adding 5 again. And this time, since we're dealing with a cube root, we're going to cube both sides. Get 8x plus 3 equals 27. Subtract 3. And divide by 8. X equals 3. So let's check and see that our solution works. We're going to store 3 for x. And then you get the cube root by doing math. It's the 4th one. 8x plus 3. And then the cube root stops after the 3, so make sure you arrow out. Minus 5. Let's see if we get negative 2. We do. So x equals 3 is the correct solution. So let's solve the square root of x equals negative 1. If we square both sides, I said we get x, and negative 1 squared is 1. But when we plug this back in, is the square root of 1 equal to negative 1? It is not. So therefore, this is an extraneous solution. So in number 3, we have a 4th root of x plus 2 plus 5 minus, or equals 3. So we're going to subtract the 5 from both sides. Then, because we're dealing with a 4th root, we're going to raise both sides to the 4th power. we get 16. Subtract the 2, we get x equals 14. So let's check and see if this works. Store 14 for x. Now to do a fourth root, we do math, and then we're going to choose this one down here, number 5, where it has an x for the root, meaning we can pick the root. So we want the fourth root of x plus 2 plus 5, and we want to see if it equals 3. It does not, it equals 7. So therefore this does not work, so there is no solution. So in number 4, the square root is by itself on the left-hand side. So we're going to square this side, and we're going to square this side. Remember, squaring x plus 5 means x plus 5 times x plus 5, and you have to multiply it out. So on the left, we're going to get 3x plus 13 equals, and when we multiply this out, we're going to get x squared plus 10x plus 25. Since we have x squareds and x's, we know we have to make this equal to 0, so we can factor it. So we're going to subtract 3x and subtract 13, subtract 3x over here, and subtract 13 over here. So we have 0 equals x squared plus 7x plus 12, which factors to x plus 3 and x plus 4. So we know that x equals negative 3 and x equals negative 4. So let's check and see if these work. We need to check both of them. So we're going to store negative 3 for x. Since we have x's on both sides, we're going to have to type in both sides of the equation and see if they match. So the square root of 3x plus 13, and we get 2, and then x plus 5 also gives us 2. So this one works. Now, just because this one works does not mean this one isn't going to work. When you get two solutions, both of them could work, one of them could work, or neither of them could work. So you need to check both. So we're going to store negative 4 for the x. I'm going to copy and paste my previous expressions. So there's the left side of the equation, and that gives us 1, and is x plus 5 also 1? Yes, so in this case, they both worked. And the reason they both worked is because when we plug them into this right-hand side, we got a positive number. Negative 3 plus 5 is positive 2, and negative 4 plus 5 is positive 1. A radical equation will have no solution when we have an even root equal to a negative number. Like here, we had a fourth root equal to a negative 2. If you multiply a number an even number of times, the answer will always be positive. So if we multiplied negative 3 6 times, it's going to come out to be a positive number. Negative 80, if we multiply it 8 times, it's going to come out with a positive answer. So that's why we know if we have an even root, it has to equal a positive number. Now, as we saw in example number 4, the x itself can be negative, but when you plug it into that side, that's when you can't have the negative. Now let's look at a couple where we have a radical on both sides of the equations. So in example number 5, we have a fourth root on the left and we have a fourth root on the right. And there's nowhere we can really move this to because it's going to be on one side or the other. It's not going to cancel out. So we're going to take both sides and raise it to the fourth power. Now, because there's no addition or subtraction sign in between these two terms, the 2 is just a coefficient. It's not a separate term. We can do 2 to the fourth and then the fourth root of x to the fourth. We can do them separately. So here we have x plus 14. And on this side, when we simplify, two to the fourth is 16. The fourth root of x to the fourth would just be x. So we subtract the x and divide by 15. And we get x equals 14 over 5. Sorry, 14 over 15. Now in number 6, our two square roots are on the same side. So if we went to just square both sides, we would have to multiply out the square root of 7x minus 8 minus the square root of 5x times the square root of 7x minus 8 minus the square root of 5x equal to 0. And we'd have to double distribute or FOIL that all out, which is going to be ugly. So what we can do to save us some effort is we can rewrite this equation to look more like number 5 did by adding the square root of 5x to both sides. So then we have the square root of 7x minus 8 equals the square root of 5x. Now we can square both sides and just get 7x minus 8 equals the square root of, equals 5x. Move 7x to the other side, get negative 8 equals negative 2x. Divide by negative 2, and we get that x equals 4. And our last type of problem. What if we have ones with rational or fraction exponents? We learned a couple lessons ago how to rewrite from rational exponent form to radical form. So we're going to rewrite in radical form, and then it'll be just like solving the ones that we did above. So we know that the denominator is the root because the roots of the tree are on the bottom of the tree. So this would be the square root of 3x plus 4 plus 3 equals 0. And now we're going to solve like we did earlier. Subtract the 3, 3x plus 4 equals negative 3. Oh look, we have a square root, which is an even root, equal to a negative. What can we stop right here and say? That's right, that it has no solution. Now the thing to be careful of, if this had been a cube root and we had started with a 1/3, we could continue on. Number 8, the 1/3 power is just for the x. If it was for this whole thing, then this whole thing would be in parentheses. So the way that we're going to rewrite this is 3 cube roots of just x. The root goes with just the x because just the x had the exponent. We're going to divide both sides by 3 to get rid of the 3 in front. Cube root of x equals 8. And then to undo our cube root, We're going to cube both sides, and we get that x equals 512. That's all for today. See you in class.